Yes. Just a minute. Yes. Sharing. Yes. Okay. Yes. Good evening, everyone. Yeah, today we are going to cover Unit 9 and Block 4 Groundwater Management, Unit 10, 11, and 12. Okay, that is groundwater management and watershed management and groundwater modeling. And in previous block, that is Block 3, Unit 9, seawater intrusion and control methods. So today we are going to this cover these chapters. I hope you have watched the previous presentations which have covered Unit 1 and 2 and 3. So today we are covering fourth chapter or fourth block. Okay, up to Unit 12. Okay, just I want to repeat yesterday's presentation. Uh, yesterday's presentation, 1 minute. Okay. Mm. Yes, I'm sharing this also. Okay, just I want to repeat yesterday's class, that is yesterday's presentation, that is groundwater contamination and what are the sources of groundwater contamination. That is block 3 groundwater pollution. I have covered unit 7 quality of groundwater, unit 8 water pollution. Today I am covering unit 9 sea water intrusion and controlling methods. And now we will talk about, just we recollect unit 7 and 8 what we have covered yesterday. See here, this is the introduction to the groundwater quality, and these are the physical parameters like color, odor, taste, turbidity, and temperature of the groundwater. And these are the chemical parameters like pH, total dissolved solids, total alkalinity, total hardness, and various major chemical constituents. Okay, like calcium, magnesium, potassium, sodium, chloride, sulfite, carbonate, bicarbonate, fluoride. These are the major chemical parameters of the groundwater quality. And these are the physical parameters. No, and water classification based on the TDS standards or TDS percentage. TDS units are mg per liter, means in 1 liter water, how many solids are dissolved in one liter of water. For example, 1 liter of water, TDS indicates 250 mg per liter. That is recommendable for drinking purpose. As I told yesterday, most of the municipality or any groundwater or water, drinking water supply system, they maintain TDS about 250 mg per liter TDS. Like that, up to 500 we can uh, consume for drinking purpose. Up to 1000 or 1200 around, we can consume or you can use for domestic purposes, and up to 2000 or 1800 we can consume for industrial purpose, and more than that, that is not suitable for industrial purpose because of total hardness and sodium percentage which is dissolved in the water. And for agriculture purpose also, there is a classification. Now we are talking about water classification based on TDS standards or based on TDS ranges. So, like here, the based on TDS concentration into categories such as fresh water, brackish water, salty water, and brain water. So, for each fresh and brackish and salty water, there is a particular TDS standards or TDS values. You try to cross check or you try to read in your textbook. And these are the major chemical constituents like calcium, magnesium, sodium, potassium, carbonate, bicarbonate, chloride, sulfate, nitrate, and fluoride. These are the major chemical constituents of groundwater. So, like physical parameters are there and chemical parameters are there. And based on TDS, we have classified into different type of water. Okay, now we are discussing about the biological impurities. So, like BOD and other coliform and other bacteria may contaminate the groundwater, and these bacteria or coliform may present in the effluent or sewage water or nala or drainage water which is coming from the our urbanization activity or our industrial activity or any these major cities, nalas, like that, these coliform and bacteria may contaminate or may growth in the groundwater. So, like that, we have covered physical parameters, chemical parameters, and classification we have covered, major constituents we have covered, biological impurity also we have covered. Okay, you have to recollect all those things. What are the physical parameters? Chemical parameter, what is the classification, what are the major chemical ions or major cations or anions which are present in the groundwater. And you should remember these coliform bacteria like biological impurities and BOD standards. And have covered yesterday this environmental impact on human health. What are the human body organs are, which organs are affected by the which type of or which type of source of pollutants, and what are the major pollutant reasons and parameters which may affect these human body. Like, just I will give one example: the bacteria, parasites, and chemicals which are present in the water pollution are biological. These pollutants may affect the our digestion system. And I will give another examples also, like these cancer risk and skin irritations may may be due to the pollutants which are coming from the air pollution and industrial pollution. Like that, each pollutants may cause some effect in the human body or human organisms. Okay, like that, you try to remember and try to watch number of times these presentation. Next, here I have covered impact on irrigation and industry. So, what are the groundwater quality which may impact the irrigation and industry? So, like that, in previous slide or first slide I have discussed, there is a ranges of TDS standards. Okay, each TDS standard or each TDS values may affect the drinking quality or irrigation quality or industrial quality or domestic usage quality. Like that, what is the impact of groundwater quality which may impact on irrigation and industry purpose, and what are the classifications which are related to the irrigation and industrial purpose assessment. Like, yeah, here I have mentioned TDS, so sodium absorption ratio, boron, chloride, sulfate, and bicarbonate. Like these are these are the chemical constituents which may affect the industrial industrial uh, pollutions or impact on industrial uh, activities. So, and when we talk about the irrigation activity, sodium percentage and total hardness, silica percent, uh, silica percentage, sorry, silica percent, total hardness, and the salinity may affect the industrial, and these are TDS and boron chloride sulfate are affect the irrigation activity. Like that I have divided what are the irrigation activity measurements and what are the standards of industrial activity affected constituents which are present in the groundwater quality. Here, just we are simply we can say that what is the impact of groundwater quality which may affect industrial activity and irrigation activity. In irrigation activity, what we have to consider, and industrial activity, what we have to consider, just have mentioned in the slide. Just try to read a number of times, try to understand. You can write or you can attempt all theory part questions. Okay. Here I have discussed what are the different type of and different methods which are included in the groundwater treatment process. So what are the groundwater treatment process? What are the methods, and which type of particular activity or filtrations methods will be there? Just I have mentioned here, and try to read a number of times and try to compare with your RO system, and this any try to visit any this municipality groundwater or water quality treatment methods. Try to visit or try to search it in Google. So what are the Hyderabad groundwater treatment process? Where are the groundwater treatment plants? What they do? How they do? What are the methods included in the total process? Try to understand. Then you can write simply theory exams, theory questions you can attempt. Like you can regard this image. These are the candles or cartridges you may seen in your homes in RO systems. These are the major cartridges may filter the minor particles or minor pollutants of the groundwater. Like that I have discussed in this slide what is the groundwater treatment procedure and methods, and treatments step by step procedures or processes. And here I have mentioned what is the environmental impact of the groundwater quality. So how groundwater quality impact environmental, and how groundwater treatment process will be there, and how groundwater quality affect irrigation and industry. Like that how groundwater quality affect human health. Like that how groundwater quality and human health, groundwater quality, irrigation, groundwater quality, industry, groundwater quality and it treatment procedure, groundwater quality with environmental effect. Like that, I have covered all the slides. What is the groundwater quality and what is the effect on different type of the activities like industrial, irrigation, environmental, human health. Just you try to read number of times or try to watch number of times. Okay, here I have mentioned what are the uh, water pollution, what is the type of water pollutions, what are the major activities which are included in the or which are present or which are may affect the water pollution, like domestic water pollution I have covered, industrial pollution, agriculture water pollution, and solid waste pollution. Just I have covered in this unit 8 what are the different type of or different type of sources which may come from the different type of activities like domestic water pollution, irrigation, agriculture water, solid waste. like that you try to read number of times. And here just with with text I have covered what are the types of pollutants and what are the major activities or major procedures which may affect the water pollution. Here I have given a image which will affect the groundwater quality. By this also, by this image also, you can write or you can answer your theory questions and try to remember this circle or these activities which may affect the groundwater quality. Air pollution may affect, improper drug disposal may affect, animal waste may affect, agriculture runoff may affect, sewage waste runoff also may affect, this gasoline leakages from industry and plant waste, manufacturing waste. These are all the pollutants which may affect the groundwater quality. Here what in this presentation in previous I have water quality and it the effect on different human organisms and different industries, irrigation and treatment process, environmental impact of the groundwater quality. Here I am discussing what are the pollutants may affect the groundwater quality. In previous slide, I have discussed quality versus different type of uh, activities which may affect quality, groundwater quality. Here, different type of activities which may leads to groundwater pollution. So, by try to understand what I have trying to discuss in these slides and what I am trying to discuss in these slides. So, I hope you are understanding these slides. So water pollution India, how much water polluting and what are the, like see here, approximately 70% of water bodies are polluted and 64% of the highly polluted industries are discharging toxic effluents in India. Like that, I have covered all the important text or important keywords which are present in the your textbook. I have prepared all the PPTs from your textbook only. So all the keywords, all the definitions, all the these data taken from your textbook only. You try to read or try to watch number of times these presentation, then you can write or you can attempt to simply, you can attempt or you can write your theory exams, theory questions. Okay, this is the water pollution in India and this is the groundwater, source of groundwater pollution like that, industrial discharge, urban discharge. Number of times I have discussed what are the pollutants and what are the activities which are related to that pollutants and what is the groundwater quality, what is the chemical parameters, biological parameters and physical parameters and what is the groundwater quality and effects on human health, groundwater quality effects on industry, groundwater quality effects on agriculture activity, groundwater quality effects on environmental and groundwater quality pollution due to the agriculture, industrial, domestic, like that I have covered. Two way I have covered quality versus pollutants and pollutants versus quality. So like that I have prepared your this presentation. Try to watch number of times. Okay, here you can see these are the solid waste or animal waste may causes the groundwater pollution. These are the fertilizers or pesticides may affect the groundwater pollution. Like that, I have covered all the definitions, all the data, all the keywords I have taken from your textbook with suitable images. The my intention is that, and I here each definition and each slide I have inserted a suitable image. By seeing this image only, you can remember the all the remaining text or headings or keywords. That's why I have inserted or I have pasted the all the related images. Try to use this material and try to attempt your theory exams. And today I'm going to cover 1 minute. And today I'm going to cover that is yesterday's presentation. And today I'm going to cover another presentation that is here. See, that is Unit 9 Seawater Intrusion and Control of Methods. And this block fourth groundwater management, like groundwater management, watershed management, and groundwater modeling. So, with this, I am going to complete all your subject, elective subject, that is hydrogeology. So, now we'll start. What is the time now? 1 minute. Okay. Ah, we have half an hour. Okay. So here, Unit 9, seawater intrusion and control methods. What is seawater? How it intrusion into the fresh water? How it contaminate the fresh water? What are the reasons? Is there any calculations? Is there any formula to identify seawater intrusion into the freshwater zones? Like that, we are going to discuss what is the seawater intrusion, how we will calculate, is there any formula, and where it will occur, how it will occur. Just we are going to discuss in these slides. You can see here, this is the image of sea water intrusion. You can observe here, this is the right side, sea level, sea floor, and this is the salt water. And here you can, left side, you can water table, land surface, and this is the sea level, approximate sea level in the earth surface, and here in the ocean, and the fresh water, and interface of the salt water and fresh water. Like that, we have divided with some formula, that is H and Z is there with some ratios. Here, slide 16, controlling seawater intrusion. What is seawater intrusion? Definition first. Seawater intrusion, the saline water mixes with fresh groundwater in aquifers. This is the aquifer. It is having fresh water. This seawater is mixing with the fresh water. That is seawater intrusion. Groundwater in aquifers, common in coastal areas due to low flow rates, high tides, and excessive withdrawals. For example, if I drill one borewell here in the surface, land surface, in the freshwater zone or freshwater zone aquifer, if I pump heavily, the seawater may intrude. This is the one reason. Like that, some excessive withdrawals and high tides and flow rates may cause the seawater intrusion into the freshwater or freshwater aquifers. This is the seawater intrusion definition. And what are the controlling methods? Here we have some methods: freshwater ridge or barrier, a subsurface or barrier construction, area-specific solutions, preventive measures like freshwater ridge or barrier. Using injection or extraction wells maintains freshwater above sea level. Okay, above sea level, we have to maintain fresh water, or you can use the injection wells or extraction wells and maintain fresh waters above sea level and prevent seawater intrusion, allows freshwater extraction. And when we talk about this subsurface barrier constructions, reduces aquifer permeability, prevent seawater inflow, protects potable water. And when we talk about the area specific solutions, detailed hydrological investigations, and understand local geology for effective controls. And if we know the geology, aquifer parameters, and what are the infiltration rates, runoff rates, what is the pumping rates, if you have these data, we can control this seawater intrusion into the freshwater zones. And last, preventive measures like avoid interaction from vulnerable sites, proactive management to mitigate intrusion effects. Like that, these are the controlling methods and these are the intrusion, seawater intrusion definition. And you can see what is there any formula? So how they will calculate, how they identify. Yes, there is a formula that is Geiben-Hertzberg relation. Geiben-Hertzberg relation. With this formula, and we can identify the seawater intrusion, how it will intrude, and where it will. Is there any level of intrusion? We can identify all factors with this formula. Here, that is, you can see here, depth of the saline water interface below sea level. Z is. And this saline water density, like that, these are the parameters. These are the parameters we have to consider for the sea water intrusion with this formula. See, depth of saline water interface below sea level, saline water density and freshwater density and height of freshwater above sea level. See here, this is the sea level. And what is the height of the freshwater table above the sea level? And Z is here you can see depth of saline water interface below sea level. This is the sea level, and below sea level, what is the interface? What is the depth of interface of freshwater and saline water? That is Z, and above sea level water table is H. Like that, we and seawater density and freshwater density and the interface depth and seawater level above freshwater, that is H. These are the main factors for main input for the identification of exact seawater or salt water intrusion into the freshwater aquifers. I hope you are understanding what is Z and what is H. And here you can see what is the interface depth of the salt and fresh water. Like that, Geiben-Herbert relation is very important, and uh, it may come in your written exams, theory exams. You may get one question about this formula, or any essay question or any short questions based on this formula. This is very important topic. That's why I have taken today. Otherwise, I could have covered yesterday only. So this is very important. That's why I'm taking today. And today I'm covering in the first session, first half an hour only. Okay, now you can observe here wetlands and groundwater recharge. So how groundwater recharge will occur? What are the factors and what are the main reasons? How will groundwater recharge? Like that we will discuss in this slide. See here, groundwater recharge sources are rainfall, runoff, irrigation, return flows. As we discussed in the first hydrogeology presentation, in hydrological cycle, rainfall, runoff, and irrigation return flows are the main sources for recharge of groundwater, and controlled, uncontrolled reservoir discharges. This is the secondary. But the first is rainfall, runoff, or infiltration, or irrigation return flow from the agriculture activity, or streams, or canals, or any lakes. And the second is factors influencing recharge or aquifer characteristics, like this is the hydrological factors. These are the aquifer factors. Like permeability, it should have confinement, 1 minute, confinement and availability of recharge areas, surface features, human activity affecting recharge. These are the aquifer related or geological rock formation related properties or factors. These are the hydrological cycle factors which may affect the groundwater recharge. Now, artificial recharge. This is the secondary recharge methods. This is the primary, and these are the aquifer parameters which may affect the groundwater recharge. And these are the main properties or main factors of the groundwater recharge or resources. Okay, now we are talking. Now we'll talk about this artificial recharge methods: flooding, water spreading, injection wells, and utilize excessive surface water, controlled releases. Artificial recharge, I think you may know the rainwater harvesting structures, check dams, contour bunds, and recharge, infiltration wells, like that. These are the artificial recharge methods. And recharge efficiency considerations are water quality, solids, chemical impurities, aquifer permeability, temperature management, optimized injection rates, and location. These are the other recharge factors for groundwater recharge. And when we talk about this importance of sustainable management, so these are the the recharge factors, different type of the recharge factors like natural hydrogeological factors are there, aquifer factors are there, artificial factors are there, and recharge efficiency considerations also there. Now we are talking about importance of sustainable management, balance extraction with recharge, prevent adverse effects, intrusion, and subsidence. Like that, these are the other important sustainable management factors which may affect the groundwater recharge. In this image, you can observe these are the wetlands groundwater or natural process. These are the see here. These are the different type of the pore spaces, and from lakes, it is getting recharged with pore spaces due to the gravity forces. Okay. From lake, it is recharging. Groundwater is recharging here. With from the subsurface or unconfined aquifer to the confined aquifer into the pore spaces. This is the groundwater table or saturated zone. Like that, by seeing this image also, you try to write or try to remember the what are the recharge factors, different type of the recharge factors. Next, next block 4, groundwater management. Here we are covering unit 10, 11, and 12. That is groundwater management, watershed management, and groundwater modeling. You can see here in this picture how we will groundwater recharge. What are the different type of methods? Okay, how we will manage the availability, quality, quantity of groundwater, and how we will improve the quality, quantity of the groundwater, and what are the suitable methods. Okay, so how we will manage. For example, in a particular area, we are having a good quality and quantity of groundwater availability is there. But if we dump disposal or any agriculture or industrial waste and without proper management, these after rain season, these improper or disposals solid waste may contaminate may pollute the groundwater. So, like this, avoiding this improper management, improper disposal, or improper dumping system is management of the quality of groundwater. And with this pollutant, groundwater quality may affect and quantity may affect. So, quantity, how will it affect? For example, in a particular area, groundwater availability, good potential zones are there. Groundwater is more availability is there, but simply they are pumping 24 hours, 24 hours by 7, or with so they are withdrawing, they are pumping more water, they are wasting more water. Like that, we have to maintain some methods to methods to control the groundwater quantity usage. So quality usage related to pollutions, and quantity management related to the how we will use, how we will pump out, how we will recharge. So in some area, groundwater availability is less. In that area, we can suggest rainwater harvesting structures. With that, we can recharge more water, and will improve the groundwater quantity. So, like that, we have to maintain quality and quantity of the groundwater. So, for quality, we have to avoid all type of pollutants. For quantity, we have to avoid pumping hours, and we have to improve the rainwater harvesting recharge methods. Like that, we will manage the groundwater management. That is only management of groundwater. So in these slides, we are going to cover these methods in detail. See here, Unit 10, groundwater management strategies and practices. Brief overview. Groundwater management involves planning and utilization of subsurface water resources to ensure sustainable development. It encompasses geological, hydrological, economic, legal, political, and financial considerations. And concepts of basin management is groundwater reservoir or basin, defined as a places where groundwater is accumulated under conditions suitable for development and use. The text also mentions terms like groundwater basin or aquifer and water bearing zone. These are all same groundwater management or groundwater reservoirs, okay, or groundwater bearing zones, geological rock formations. And in groundwater basin management's program for development and utilization of subsurface water, considering geological, hydrogeological, and hydrological, economic, legal, political, and financial aspects we have to consider. And balance between extraction and replenishment is extraction of groundwater affects its replenishment, and integrated approach is essential for sustainable management. Integrated approach. What is integrated approach again? Coordination of surface water and groundwater resources for optimum economic development. That is integrated approach. Additionally, the text emphasizes the need for action decisions by appropriate public bodies or agencies. Like that, we have to maintain the groundwater and with the surface water, and we have to maintain groundwater basins and reservoirs, and with the integrated approach of the surface and groundwater resources. Next, we are just I have given here one picture. With this, you may recollect or remember this. See here, the snow, glaciers are there, lakes are there, streams are there, and interspection is there, reservoirs are there. Okay, here. Next, what is the next level? Usage. Industry they are using, and desiltation is there with the usage. And here, this side you can observe, this is the industrial usage. Okay, and here this is the right side, transpiration, lakes, transpiration, reservoirs, and households are domestic usage. And some water with in rainfall, evaporation may there, and soils may take some water, and livestock and some groundwater may available with the runoff and infiltration activity. Here you can observe that this is the agriculture activity. These all activities, households, livestock, agriculture, and industry are depending on this lakes and reservoirs or rivers water availability. This is the availability, and these are the users, different type of users. Then from each user, groundwater may affect, quantity may affect, and quality may affect. For example, industry is there, it will use some amount of water, it will release some effluents, some pollutants from industries, and in agriculture activity also, they may use some water, and there may be a return flow, recharge, and there may be a agriculture pollutants contaminating the uh, groundwater. Here, households also, they may release sewage water or drainage water or wastewater into the nalas. Again, nalas connects with the natural streams, and they may reach the groundwater with the infiltration, percolation, capillary rise. Like this, it will finally from lakes to, or here from snow, glacier, like transpiration, reservoirs, all it will reaches these different type of activities, and it will collect this water, it will collect some pollutants, and it will join in the groundwater. From agriculture also there may be pollutants, from households also there may be a pollutants. Like this quality of groundwater and quantity of groundwater is affecting. That's why we have to manage these household systems, proper management of sewage system, proper management of agriculture, fertilizers, pesticides usage, and proper management of industries, sewage water or effluent water. Then they should have some treatment system. Each industry should have some treatment system, that is effluent treatments, ETP, effluent treatment plants they should have. In agriculture activity also, they should maintain some fertilizers and pesticides control. And these households also, they should maintain some proper management or proper dumping of solid waste and liquid waste. Here, after finally, due to the infiltration activity, percolation activity, pumping activity, capillary rise, and base flow, interflow, surface flow, all with all the activities, these pollutants are these chemical and physical constituents of the groundwater quality may affect quality and quantity or availability of the groundwater. Like that, if we manage these systems, these stakeholders are these users. These are the first users of the available water, surface water. Okay. So if we manage these systems, then we can manage the quality and quantity of the groundwater. Like this, by seeing this image, you should remember or recollect when you are writing your theory exams, when you are attempting your theory exams. Here you can observe some slides. Groundwater management challenges like potential not assessed, uncontrolled groundwater explorations and development, fragmented data and information, land degradation, some aquifers in six basins are transboundary, and weak legal framework, capacity to management. Like this, these are the main challenges may affect the groundwater quality and quantity management. So these are the main challenges. And here you can equation of hydraulic equilibrium. Just you can observe here hydrological equilibrium. 1 minute, I will check.